Hi guys, today we're going to learn about thermochemistry. The first law of thermodynamics states the total energy of an isolated system is constant, meaning energy can be neither created nor destroyed, but only transferred or transformed. In an endothermic reaction, heat is absorbed from the surroundings. This means an endothermic reaction is cooler than the surroundings. In this case, the ice cube is cooler than the surrounding air. In an exothermic reaction, heat is released from the system to the surroundings. This means the exothermic reaction is hotter than the surroundings. In this case, the fire is hotter than the surrounding air. A good way to differentiate between the two is by using En, which sounds like in, or rather, the energy or heat is going into the system, meaning this is adding energy to the system. An exothermic reaction, Ex, sounds like exit, meaning the energy or heat is exiting the system, which is losing the energy from the system. In thermochemistry, we're very concerned with the change in energy, which is E final minus E initial, or E products minus E reactants. So if delta E is positive or greater than 0, then it is an endothermic process. If delta E is negative or less than 0, then it is an exothermic process. An important note to make is the SI unit of energy is joules, which is equal to newtons times meters, which is also equal to kilograms times meters squared over seconds squared. Below are some example problems which we're going to have you state whether this is an exothermic or endothermic reaction and indicate the sign of flow, whether it be negative or positive. So go ahead and pause this video so you can answer the questions on your own. Number 1, melting ice cubes. Melting ice cubes is an endothermic or heat going in reaction. This means that the energy flow is going into the system. Another way to think about this is that the system or the ice cube is cooler than the surrounding air. Number 2, candle flame. So this is an exothermic or heat is going out or exiting reaction. So this is the system itself, which is the flame, is losing heat. So this is a negative sign of flow. Number 3, formation of snow in clouds. So again, this is an exothermic reaction. So this is negative. This means that the system is becoming cooler. So the snowflakes are becoming cooler. Number 4, baking bread. This is an endothermic reaction, meaning in order to make this bread, there must be an energy flow, a positive energy flow to the bread. Okay, and the next part we're going to go over is the first law of thermodynamics in terms of heat and work. The formula for this is delta E, change in the system's internal energy, is equal to Q plus W, which is heat transferred plus work. So it is important to note what sign work is. So if work is being done on a system, then the work is positive. If the work is being done by a system, then the work is negative. Let's go ahead and go over a check of understanding. Go ahead and pause this video so you can answer these questions on your own. Okay, now that you've answered these questions on your own, if Q is blank, system released heat. So if Q is negative, system released heat. If Q is positive, system absorbed heat. If W is negative, system did work. If W is positive, system had work done on it. Go ahead and pause this video so you can answer these questions on your own. Okay, after answering these questions, let's start with number 1. Write the sign of Q and W that represent a system that is doing work on the surroundings and losing heat to the surroundings. So for Q, we know that the system is losing heat to the surroundings, so this is a negative flow of energy. For work, we know that the system is doing work on the surroundings, so this is also a negative flow of energy. Number 2, a system released 200 joules of heat and does 250 joules of work on the surroundings. So what is the change in the internal energy of the systems? So a good way to represent this problem is through a picture. So a system released 200 joules of heat. So this is releasing 200 joules of heat into the surroundings. The system also does 250 joules of work on the surroundings. So this goes from the system to the surroundings. So in this problem, we're going to use the equation delta E is equal to Q plus W. In this case, Q is equal to, since it's going from system to surroundings, negative 200 joules of heat. And then W, which is work, since the system does work on the surroundings, this is also negative 250 joules. So delta E is equal to negative 200 joules minus 250 joules, which is equal to negative 450 joules or negative 0.45 kilojoules.